Hey ChemStars, this is Mrs. Vanderlei bringing you Chapter 12 Solutions and Molarity Review. If you're in Level 2, this is page 8. If you are in Level 1, this is page 10 of your homework packet. Now, the premise here is that you've already watched all the videos and that you have already done this review sheet. So this should be filled out. If you haven't filled it out already, then pause this, work on it, and then come back. You're going to learn a whole lot more by checking your work than just straight copying your work, all right? So if you don't already have your calculator handy, why don't you also have that out, okay? So let's begin. Number 1, calculate molarity. What is a molarity of 33.5 grams of ammonium carbonate in 50 milliliters? All right, so I need to find, well, what do I need to find first? Let me think. What's always your first step? Yes, it's to find moles. So can I use this equation right here to find moles? Molarity equals moles over liters. And is that moles, right? No, I can't do that. I don't know molarity. I have volume right here, which I can convert to liters, but I don't know molarity, so I can't solve for moles this way. Okay, so how am I going to solve for moles? Hey, I can do it from 33.5 what? Grams, periodic table. So this is the molar mass of ammonium carbonate, okay? So now I can solve for moles, which is always your first step. So I can put that 96.11 grams on the bottom, so the grams will cancel. Mole goes on top because that's what I'm looking for. So I get 0.349 moles with 3 sig figs. So now I can solve for molarity. Molarity is equal to moles per liter. And so I now know what my moles are. It's 0.349 moles. Now, what about this? This is not in liters, is it? This is in milliliters. So how do I convert milliliters? What does milli mean? Milli means 1,000. So I need to take 50 divided by 1,000. If you need to, use your calculator. And what do you get? I get this. For a molarity of 6.97 molar. All right. Now, the next one is all about dilutions. All right. So if you're going to dilute something, all you're going to do is add water. So if I have a 2.35 molar solution of sodium chloride table salt, all right, and I'm going to add water to it, notice that moles don't change. You have the same number of moles of sodium chloride before you add the water. Well, what does moles equal? If you want to do your moles on top of the mountain song again, which I know you're just dying to do, all right, so moles on top of the mountain, moles is equal to molarity times volume, isn't it? Times liters. So we can say the molarity times volume before equals the molarity times the volume after. Why? Because that's what moles before is. Moles is molarity times volume. Moles is molarity times volume. So now what? I just plugged in the number here. So the question is, if I have my stock solution, all right, that is 2.35 molar, how many milliliters do I pour out of my stock solution into my graduated cylinder? That's what your V1 is really asking for. And then once I put it in a 250 milliliter volumetric flask, maybe I should put it over here. Here we go. I want to have a molarity of 0.12. So again, my V1 is how much of my stock solution do I pour into here? And then I'll pour this into here and fill it up to the line, and I'll have a solution that's 0.12 molar. So that's what your V1 is all about. How much do you pour out? All right, so how do I solve for V1? I'm going to take 0.12 times 250 mils divided by 2.35 molarity, and I get 12.8 milliliters. Let me just show you something real quick. All right, my molarities cancels out, don't I? So if I left this in milliliters, what unit will my V1 have is milliliters. So what does that mean? I'm going to take some of this and pour in the graduated cylinder. How much? 12.8 mils. All right, so once I've carefully measured out my 12.8 mils, what am I going to do? I'm going to then pour my 12.8 mils into here, Fill it up to the line, all right, that's marked on your volumetric flask, and then therefore this solution will be 0.12 molar, okay? Hopefully that helps. Let's go on to the next problem. So it says, write out the balanced equation, including products, all right? So what's going on here? I am going to combine sodium carbonate and calcium acetate. Well, how are you going to predict the products on this one? We have an ionic compound and we have an ionic compound. So what happens when we have an ionic and an ionic? Do you remember what happens? We call that a double replacement, don't I? What does that mean? The nonmetals swap, all right? So here's my equation. Notice how sodium is with carbonate first? Sodium is now with acetate. See how calcium is with acetate? Now it's with carbonate. Now, how do I know these formulas are correct? The charge of sodium is +1, acetate's -1. How did I know that? Some of you may have memorized it. Some of you may have to look it up on your chart. Either way, acetate's -1. Calcium is +2. Why? Because it's in group 2. What's carbonate? -2. Again, some of you may have memorized that. Some of you may have looked it up on a chart, but a +2 and a -2 cancel out. So those formulas are correct. So what's left to do? I need to balance this, okay? And man, I see a lot of C's and O's. Let me balance my metals, the sodium and the calciums, and let's see if that helps. Here I have 2 sodiums. Here I have 1 sodium. That 2 goes with the carbon, not with the sodium. So I'm going to put a 2 here. I have 1 calcium and I have 1 calcium. And you know what? If you keep working, that works. All right. So let me go ahead and fill the rest of it out. I need some more information, don't I? Oh, here's some information right here. If I have 1.75 molar of 0.5 mils of sodium carbonate, well, how many moles is all that going to be? Well, I don't know. So isn't that equal to molarity times volume times liters, right? And so when I multiply those two numbers, I get 0.875 moles, all right? So I'm going to use 0.875 moles right here. Now what? I need something about my calcium acetate. Well, what do I know about my calcium acetate? I know that I have 2.75 molar solution and I have 300 mils of it. So how many moles is that? Well, isn't that equal to molarity times liters? Well, yes, it does. All right. And so I get 0.825 moles of that. So let me put that up here. Oops, I need to scroll back up again, don't I? All right. So now what? Well, how many moles of, I don't know, sodium acetate do I start off with? None. It's a product. All right. And I have no calcium carbonate. So now the question is, which is my limiting reactant? That was from chapter 9. Do you remember that? Well, which one's going to run out first? And if you're looking at your coefficients, what does that tell you? That they are both 1. So that makes life so much easier. So if it's a 1-to-1, whichever one I have least amount of is going to be my limiting reactant, and that's your calcium acetate. So I have, I'm going to subtract 0.825 on both sides, okay? Or on both reactants. So I'm going to get a 0 here and a negative, I'm sorry, and a 0.50 moles of sodium carbonate. So now what? I need to fill out the rest of these, don't I? So what's 0.825 divided by 1 times 2? That wasn't too bad. What's 0.825 divided by 1 times 1? Well, that's even easier, isn't it? Oops, come on up here. All right. And so now I just have to add a few things, all right? And so I get 1.65 here, and I get 0.825 here. So I filled out my BCA. So now what's left to do is to answer part C. How many grams of calcium carbonate are actually made? Well, let me scroll back up. I have this many moles of calcium carbonate made. So now I have to come up with how many grams. You just probably had a sneak preview right there. I need molar mass. Why do I need molar mass? Because I'm looking for what? Grams, periodic table. All right. So how many grams is 0.825 moles? I'll put 1 mole on the bottom. 100.09 grams on top, and I get 82.6 grams of calcium carbonate made. So I hope this was helpful, and that's the end of chapter 12. So don't wait to be great. We'll see you next time. Bye-bye.